All right, this is our CT group project by Mark Anthony, Lilly, and Areli. We chose the scroll movement, and its prime movers are the quadriceps, which extend the knee as you stand up. Synergists like the hamstrings and adductor assist with hip extension and stability. Stabilizers include the abdominals, erector spinae. They help with maintaining posture and balance. In terms of the joint arm and lever arms, as you squat deeper, the lever arm increases and muscles need more force to produce the same torque. If torque is 300 Newton meters and the lever arm is 0.25 meters, the force is 1200 newtons, and when the lever arm shortens to 0.15 meters near the top, force demand increases to 2000 newtons. Bodyweight squats mainly rely on oxidative phosphorylation since they're lower intensity and done for longer durations. The primary fibers used are slow twitch oxidative fibers to support endurance and stability throughout the movement.
During a squat, muscle contraction happens through EC coupling. The brain sends an action potential through motor neurons to the quadriceps and glutes. When the impulse reaches the axonal terminal, acetylcholine is released, binding to receptors on the muscle fiber and causing depolarization. The action potential travels along the sarcolemma and down the T tubules, where the DHP receptor activates the ryanodine receptor on the sarcoplasmic reticulum. This releases calcium into the cytoplasm, and calcium binds to troponin, exposing binding sites on actin so myosin can attach. This leads into the sliding filament process. Myosin heads pull on actin using ATP, shortening the sarcomere and generating force. ATP also allows myosin to detach and helps pump calcium back into the SR for relaxation. Together, these steps turn the electrical signal from the brain into the smooth, powerful movement needed to perform a squat.
For the dysfunction, which is improper squat depth, the muscles that are overloaded are the quadriceps, such as the rectus femoris and vastus lateralis, which take on most of the load. The energy system that fails first is the phosphocreatine system. As activity continues, the anaerobic glycolytic system tries to compensate, but also leads to muscle fatigue. At the cellular level, calcium dysregulation, repeated contractions deplete the SR calcium handling efficiency, which could lead to impaired cross-bridge cycling. ATP depletion reduces the ATP or impairs the myosin head detachment, resulting in stiffness or cramping. With both combined, it results in failure of EC coupling and disrupts coordinated contractions. And different movements for corrections. We have movement correction, which is practice proper squat depth. For the second one, strength balance, which incorporates posterior chain exercises to balance anterior and posterior load. Third one, energy system training for power and endurance. And the fourth one, injury prevention, which includes mobility and stability training for hips, knees, and ankles.